Okay, so welcome guys to my tutorial. So today we're going to be doing something that is more fun. As you can see on the screen, we have these words. They are, if you can't read them, it spells out Blender. And if you look here down in the geometry node, we have the same word typed into the string node. And what we're going to be doing is to create a geometry node system that converts the strings that you're seeing right now into these letters that you have here. So we're going to, for example, type in here a word like love maybe, and automatically you see the word turning in form of these letters, or maybe something like CG build up, the name of my YouTube channel, and just like that you see it coming, CG build up, or maybe something like subscribe if impressed, and there we go. And I know I said that this works for Disney letters, but you can actually do with other fonts. It works by a collection, and I have a bunch of letters here, but I'll just show you this other one, and it's called monster letters. And as you can see, it's spelled out subscribe if impressed. And we can also type in another word like the same back again, Blender, or maybe even I love meatloaf, and it's will spell the same. So this is what we're going to be creating, converting a string into this fun loving words that you're seeing right now on the screen. We'll select everything and just delete it, and I'll add in an image as plain, and I'll just go to the file view and go to wherever I saved and select and import it. Now I'll head over to the materials, and as you can see, these are the materials, the image that we are going to be working with. So I'll head over to the cycles next, and I'll change the view transform from filmic to standard, and that makes the color even better. Okay, yeah, then I'll just move this up and go into the shader editor. Instead of this image going to the BSDF, let's just connect it to the surface and we get something like that. Then we're going to add in a mix shader. We're going to actually mix this with the transparent, and this is going to be there, and the transparent is going to be here, and we connect this alpha channel into the factor and we get something like that. And that's for the materials, and I'll also make sure it's alpha hashed, yeah, something like this. And going back here to the timeline, and I'll just reduce this just like that. Afterwards, I'm just going to edit mode. So first of all, we're going to cut each letter here that we're seeing so that it can have its own face, and we're going to use a knife tool, just clicking and cutting, just some small basic modeling. Okay, and in this part I think I'll do a time lapse, so afterwards I just do a time lapse here. Okay, so the cutting is done. So what I'm going to do next is just select everything, go to the edge mode and select edge split. Afterwards, we are going to move individual parts like this one. Let's go to faces, select this part and grab it, move it there. We're going to grab them so that they spell out A, B, C, D, E until Z. And grab this part, move it somewhere there, grab this part, move it there, and finally the last part and there. Okay, this arrangement that it goes from A to Z according to our view is going to be very important, especially when we are going to do some mapping of some sort. So what I'm going to do now is we're going to separate by loose parts. Okay, and I'll select this part here, this very bottom part, and just delete. And we're going to select everything and make sure you set origin to geometry. See this flow whereby the origin of A is the closest to 0 or the lowest, then Z the farthest. Depending on the X is going to be very important. I'll show you how important it's going to be. Next up is going to move this into its own separate correction, which I'll just call it letters, and press OK. And my preference is to swap these areas, and I normally like it to be this way. And I'll close it, go to the previous collection and go to the here and geometry nodes. Not it. So we're going to add a plane, then we're going to add in a geometry node and give it new. Go to the geometry node workspace and reduce this to a straight window. Look at it from the top and let's dive in. So first thing, we're going to add in a string to curves node, and we're going to type in A to Z, okay, in the order that we arranged, and we're going to use capital letters for this. It's very important that you use capital letters, not small letters, because capital letters are better and they don't have like two parts in a letter. Their problem is that there are some letters that have holes, and we're going to eliminate that problem. So just type in A to Z. And we now have instances of these letters, and there are 26, just the right amount that we need. So next up, we're going to fill all these letters with some faces, okay, because we're going to find a way that A will be equal to 1, B is equal to C, D 4, and so on, and Z will be equal to 26 or 25, because and I'll show you that way. Okay, I'm sorry for the stammering. So we're going to fill this by first realizing these instances. Afterwards, we're going to add in a trim curve node. We're going to fill not using the fill curve node because sometimes it's very slow in some aspects. So we're going to do it my way. So we're going to convert this curve into a mesh and use domain size. Then we're going to add in a circle, a mesh circle, and we're going to fill it with an end goal, and we're going to connect the points into the vertices. Then we're going to add in a set position node. Then we're going to do a sample index from this mesh that's coming from here, and connect this mesh into here, and connect this from float to vector, and connect a position node. In the index, connect the index. Okay, then it's going to look weird once I connect the vector into the position. And what we need to do right now, we have to merge this by distance. It looks better, but it's still awful. That's because if you look here, we have 35 faces, okay, but we need 26 faces, and it just occurs that one of those faces is connecting through all mini faces that we have, like all splines that we have. See here, we are having 35 faces, but if you come to here in these curves, we're having 34 splines. So there is that one face that is connecting throughout all these splines, and we have to eliminate it. But something that is very important also is to make sure the character spacing is enough for this to work, and the character spacing should always be enough to maintain that distance between characters. So what we're going to do is that we're going to capture an attribute here of a point. Make sure it's point, and that is going to be the vertex neighbor. Okay, then we're going to delete a face, and the face that we're going to be deleting, we want actually in this case Blender to do some interpolation of this. We want to say, is it greater than 3? And if I connect this like that, you see right now, instead of having 35 faces, we are having 34. That is equal to the number of splines we are having. So another problem that we are having in this case, we have holes. Okay, we have faces on top of faces, and these we won't be needing them because they'll make our calculations very terrible. So what we're going to do now is we're going to set the position of every face along the z-axis according to their face area, and we're going to actually multiply this, multiply it by a larger number, like 10 maybe, just to make sure to increase the possibility of the accuracies. Then from this, we're going to connect a raycast node, and the raycast node, we're going to use a ray direction of 1 in the Z, which is here at the bottom. In the source position here, we're going to offset the position of the vertices along the Z by writing here something like 0.001 is enough. And we're going to add in a delete geometry node, and we're going to connect this is hit into here, and by doing that, we see each letter has no holes in them. I can call them holes. You can see like this, A here had a face in the middle, P had a face in the middle, Q had that face in the middle, R, and so on, like A and B. So now we are done with that. Now we have to find a way for Blender to recognize these faces. See, we have here A, B, C, D, E, F, G. We want Blender, whenever he sees a face that looks like this, or B looks like this, C looks like this, D, it recognizes as A as 0 or 1, B, and so on, like a gradient moving from A to Z. Actually, in this case, what I came to realize when I was working with this, let's just use a viewer node, and I want to show you that look at how the mesh island index flows. The mesh island, and we're going to set this to equal by using a compare node and see what happens. A is 0, B is 1, C, and so on, as you can see. So what we're actually going to do now, it's because of how we arranged our letters initially in this string. But what we're going to be doing in the future is that we won't always want A to be the first letter, B to be the third letter, C, and so on, stuff like that. We actually want, like when I type in another string, like let me connect this to a string, something like Blender, okay, and actually view this again by using the same mesh island index. We clearly see it's still going to recognize the same. It's going to see B as 0, L, just because of the order that we went. So we're going to find a way so Blender can actually recognize this. And the best solution that I found is the same way we set the position of every point according to their face area. So I'm going to delete that, and I'm going to set the position of every point along the z-axis according to their face area. Now what we just made here is going to be very important in the future, that we will need a node group for this whole thing. So I'll just group this, and the parameters that we actually would be in need of controlling is the string, the size, the character, and the word spacing. And I'll tab out of this and let's move on. Okay, our strings have not disappeared. Remember, we just set the position of every point according to their face area. Now let's add in another one here, and I want to show you something. Okay, we're going to do sampling. So this one here, I'm going to type in another word completely, like maybe I love Blender. Okay, then we're going to connect this into a viewer node. Then we're going to be sampling sample index of every point, but actually be doing by sample nearest. And we're going to connect this point in the index, this index to index, and we're going to connect this, instead of float, we're going to use integer, that is the index. And in the position here, we're going to be using the same as before. I want you to see what happens when I say equal and connect this one into the view. Everything is black, not to worry, but look what happens when I go to 1.
It was at this moment that he knew. He fucked up.
Okay, I mistaken. We're not actually in need of the index. We actually need of the mesh island index. Now it's everything is okay. So 0 for A. So if I type in something like, we connect a string to this, If I type in something like A and enter, it recognizes it. If I type in like something like B, F, G, something like that, it recognizes B, and it doesn't. C is 2, D is 4, D is 3, then 4 will be F. No, 4 is E, then 5 is F, then the following is G, and so forth. So we have this information that it's going to be very useful to us. So we're going to capture it. And connect this one into the capture attribute, and actually this is an integer, and control X that and grab it there. Okay, so what about our collection that we have there? So let's deal with that now. So each letter knows its index, and each letter, according to how we know, according to our alphabet flow, A is 1, A is 0, B is 1, C is so on like that towards this end. But let's check our instances that we're going to be using via the collection. We're going to keep letters, and clear your letters are very small, something like this. Then we're going to keep separate children, and we don't actually want original, we need relative, and like that. So first thing to do is let's check about the indexes, how they flow from A to B. So I'm going to use a compare and index, use index, and this is going to be of every instance. Use integer, and as you can see, the one who has an index of 0 is all the way that way, 1 is this way, 2 is that way. They are in unpredictable manner. So despite our letters go in a direction of A is 0, B is 1, these indexes are not arranged in the way we would expect them to be. So how will each face here realize which index to pick here? Now there are two ways, and the one that I don't suggest that you do at all is by using the float curve, whereby we map what is 1 to be what is supposed to be, 2 to be what's supposed to be, which would be a very long way, and I would never suggest you do that. So what we're going to do is that we have this bunch of points, bunch of instances, then we're going to convert them to points. Okay, instances to points. I'll just hide this collection and go to the materials, and what we're going to do is we're going to convert them to vertices. Points to vertices, and also we don't want them to be in any location than the X, so we're going to set their position so that they have only a value. Their position is always going to be only in the X. So next up is to make sure these points, that the first one is in the 0 position in the meter, the second one 1, 2, so forth, that the distance between this point, regardless of where it is, the first one becomes 0, the second one, so forth. That's that the distance between these points is 2 meters relative to the nearest points. So how are we going to do that? So first order of business is we're going to do some instancing on these points, and we're going to instance them mesh cycles. And we're going to realize these instances. Let's just view this, and they are so big, and I'm just going to reduce them to 0.1, and we have to fill them for what we're going to do to work, and we're going to reduce them to 3, because if there was a possibility of having even a face with 2 vertices, we could do it, because what we're going to do is ray casting, and the ray casting will not be in need of the position of any of these points, but rather the position of the faces. And also we'll have to rotate this by 90 in the Y. You might not be able to see their faces, they have not disappeared, they're just very perpendicular according to our view. And from these realized instances, we'll be in need of connecting the raycast, and it should wait over there. And going back to these ones, we're going to extrude. Okay, we're going to do some extrusion of the vertices that we have here, and here we have, and we don't actually want them to go anywhere. We're going to set their positions ourselves. So we're going to do a set position, and what the vertices we're going to be setting their position are those that are from the top, and those that actually are going to be hit from this is hit. And we're going to connect the boolean into the selection. Now, right now, if you connect this hit position into the position, nothing will happen, because the position of each face is equal to the position of every vertices. In order for it to work, we'll have to offset the source position, and also we'll have to change this from the ray direction to 1 in the X. Now you see a little line that has been formed here, but yeah, that's highly inaccurate. So what we're going to do here, we're going to first add the position, and we're going to connect this to a combine XYZ, and in the X we're going to use a vector math divide. Instantly you see it working, and in some cases it is correct, but in some cases it's not. So just have to offset it a little, just by 0. Yeah, that it works. Then afterwards, I want to see that if you merge by distance right now, we have 25 edges and 26 vertices, which is perfect for what we're going to do, and I will show you exactly why. We're going to convert this to curves, because curves indices flow in a linear and perfect manner compared to meshes, whereby the start point has the lowest index in that curve, and the end point will have the maximum index in that curve, and that flow is very useful in so many situations. I can't name how many. So convert these meshes into curves. We're going to set their position. So this is that part whereby if I do a combine XYZ, and in the X I connect it to a spline parameter index, not length or factor. Each point, according to its index, will have its position in the X, and that is perfect, especially for doing some mapping according to proximity. So what we're going to be transferring is first a captured attribute, okay? And this is that moment that you just want to use the sample index itself with sample nearest itself without a sample index. So what we're going to do is this indexes from this point, we're going to do a sample nearest. And this capture attribute should be set to index, an integer I meant, and this is going to be connected here. So despite this, guys, these indexes are from different points. We are not supposed to capture it from here, because remember each point comes from a different 2 or more points, something like that. I can't explain how, but each point has its own, it comes from 2 points which had different indexes. So capturing those indexes and saying that we sample them in the later is not going to be useful, because you get interpolated results, not results that from one point that made them. So sampling is the best solution to this case. So how are we going to sample? We're going to, first of all, going to lower this down and just grab it somewhere here. Grab this here. We're going to do some sample index here, but before that we're going to do the sample nearest index and connect this one here. Sorry, it's supposed to be sample nearest, my bad on that. Sample nearest, and connect these indexes to the indexes, and the source position is going to be the same combine XYZ, but this time instead of using whatever we did here, using the face area, so we're going to connect this captured attribute into the X. Okay, and let's just go back here. Let's see how it's going to work. And connect this here. Grab it here. So we're going to be doing some instancing. Instance on these points. And what we're going to be doing is instancing on the mesh, on the faces. So before going any further, so it's mesh to points, and we're not saying vertices, we're saying faces. Okay, and for the indexes we have our collection here, and I'll raise it up a bit, take this into there, and we have every of our instances on each point. But what we want to do is pick these indexes, pick these instances, and connect this value here. And if you go to the materials, we have two problems. First of all, they are all single letters. Second, they are very far from the original. So to solve this, we have to capture the information before converting them into points. So connect set this to indexes and connect this to that and this to that. And we say this to be of every face, and it's not working because of this sample indexes, but it should be meshes. So we're going to convert this into a mesh, and there. And another thing that I forgot, that in this index, in this value, we are supposed to connect here this value. And now if I type in something like Blender, it works correctly. That if you zoom in, we have E there, L, E, and it's okay. But the problem is, first of all, I forgot I had to set their position so that they're all in the Z. So combine XYZ, multiply position, and set them flat. So there is that problem, and that problem is mainly caused by this collection info set to relative. So, and we needed that relative, but to get the best of both worlds, we're just going to translate these instances, and we're going to scale by -1 their positions. And just by doing that, things are looking better. As in, if you take all this and just mute, you can see averagely they are in the correct position, but in the wrong scale. So we can connect this the value node and scale them, something like that. And then the remaining thing that is to be done right now is just to remap. Okay, just to open these letters here and select all of them, grab them along the Y, and do sort of remapping by the following way. Okay, so we're going to join geometry, then from here we're going to delete all faces and only faces and connect them there. And what I would advise you to do right now is just to tab into edit mode, and when you see like B over here, you grab it in a gentle way by pressing shift and move it around, not by selecting instances, but by selecting them from this line, from this level. And if you see L is in the wrong place, you grab it ever so gently and move it like that. When you see E in the wrong position, you grab it. You can also scale. And this is actually the end of the tutorial. So if you liked the video and found it useful, always a like and a subscribe means a lot to me, and I will really appreciate that you will be supporting me a lot.